If you look at the best in the world in terms of like bipedal dynamic walking today, whether it's us or Boston Dynamics or the rest, you can see like really robust systems that are able to reason and articulate almost like better than a human in some ways. I would say at this point, the locomotion side is as good or potentially maybe better than a human. I mean, you see some robots doing like front flips and back flips in terms of how well they can basically interact with the world. So we feel like that space just wasn't possible 10 years ago. The sensors and algorithms around being able to control those robots and even the AI training systems around that have gotten so robust that we think this is like a solved space. We're making a lot of improvements in this area, but it's definitely sufficient to be able to introduce robots into real operations. So the first one is like basically bipedal locomotion. 10 years ago, not really possible to do in real commercial viability. The second is we need a certain amount of power and torques in the motors to be able to lift a certain amount of objects and manipulate them. And we need a certain amount of runtime in the system to be able to do like real, hours and hours of daily operations. So the energy and power density in both the battery systems and the motors or the actuators were not energy or power dense 10 years ago to be able to do real operations from electromechanical perspective. If we wanted to use batteries and motors, you look 10 years ago, you see some robots like Boston Dynamics were all hydraulic to basically get the like basically the torques and powers they really needed to basically move around the physical world. Today, our system is all electric. We use like basically 2170 like basically energy cylindrical cells that you would see in electric cars, and we have electric actuators that are basically electric motors with rotors and stators that allow us to basically build a really like I would say relatively simple and safe and high power and high energy system.